Hey, very good morning, all my dear students. How is everyone? So today, really, we are going to start with the fantabulous chapter that is being Isomerism. Here is your HSP hour on your NEET Unacademy English channel. So kids, today, definitely we are going to start with the awesome chapter that is being your Isomerism. So, before I'm going to start, do let me know everyone, am I audible and visible to all of you? Yeah, there was some technical glitch, that's why I got 5 minutes late. Sorry for that, really extremely sorry from the eternal core of my heart, kids. But before I'm going to start with this awesome chapter of Isomerism, first of all, I would like to see that am I perfectly audible and visible to all of you? If yes, just to let me know in the chat section. So, Swagatam, welcome to all of you. Vanakkam, Vanakkam, Sasrigal, Shuprabhat to each and everyone. So, kids, there is a short introduction of myself, your HSP Baba. I did MTech in 2005. Yeah. That you must be thinking 2004 or 2005. That at the last of 2004, so I can say 2004 or starting of 2005. And I am gold medalist in MSc, 2 postgraduate degrees I'm having, and after MSc I did JRF and qualified GATE. Then I got admission to MTech. Now kids, if you are new to this channel, do subscribe the channel. Don't forget, do subscribe the channel. And kids, what is this? Number of students I can see, but so less likes. You are not going to give likes to your HSP Baba. That means you don't love your HSP Baba. Kids, I want to see likes to be more than 100. At least get 70 likes I want to get. Yeah, yesterday's homework question. Definitely, I'm going to give the hint for yesterday's homework question, but that I will give at the last. At the last, definitely I will let you know what was the homework. Yeah, I can't give like because this is my first class. Okay, no problem. Those who are having their first class, no worry. Now kids, do subscribe the channel if you're new to this channel. And kids, this is the definition of isomerism. This is true or false. Do let me know in the chat section. This definition of isomerism, you must have seen the definition of isomerism. Just do let me know in the chat section that surprise of course. Kids, this is free of cost. This is Achievers Batch. It's free for each and everyone. Kids, no price. Just I need your time. But kids, do let me know this definition of isomerism. You must know from the class 9th, 10th or whatever I can say. You must know the definition of isomerism. Would you are saying this is true or false? I want to see your answer. This definition is true or false. Kids, do let me know this definition is true or false. What's your suggestion? True or false? Will you say true or false? Because whenever we are going to deal with the isomerism, everyone, we have to definitely go with the definition of isomerism. So everyone is saying true. Kids, everyone is saying true, but do remember kids, examiner will give you a big 0, double 0 if you are going to write this definition. This is absolutely wrong. Absolutely wrong definition, kids. This is absolutely wrong definition, wrong. So, false, not true. Now you will say, sir, we have studied this definition only, and you are saying this is false definition? How can we believe? Just prove it, sir. So kids, I'm going to prove that this definition is absolutely wrong. See to it. See to it. See this example, kids. You know very well that this is cis, that is trans, and these are known as geometrical isomers. These are known as geometrical isomers. Am I right, kids? These are known as geometrical isomers. So their structure is same. Why their structure is same? I would like to say both of them are butene. Both of them are butene. They are butene. Kids, butene. That means their structure is same. Their structure is absolutely same. Same structures. Their structures are not different. Their structures are same, but then also they are isomers. They are isomers. Their structures are same, although their structures are same, but then also they are isomers. They are isomers. So what conclusion we are going to get? That it's not necessary that they should have different structures. Their structure can be same or they can be different. That's why there is one type of isomerism that is known as space isomerism. Just they have got difference in their space orientation. Difference in space orientation. Difference in space orientation. So kids, let me tell you what is the true definition for isomerism. This is the correct definition for isomerism. Compounds having same molecular formula but different physical or chemical properties. Their physical or chemical properties can be different or both may be different. Kids, do remember. Kids, somebody is asking for Avengers batch. This is Achievers batch. At right now where I'm teaching on YouTube, kids, this is Achievers batch. So do remember, compounds having same molecular formula but different physical or chemical properties of both may be different. This is the correct definition and you should keep it in your brain. Now kids, let's start. How to find out? I'm going to give you the trick. Awesome trick to find out total number of structural isomers. Total number of structural isomers. So kids, definitely this is going to be the awesome trick that how to find out that particular compound is having how many total number of structural isomers. See kids, if I talk about CH4, if I talk about C2H6 and if I talk about C3H8, they don't have any structural isomer. So better to say they don't have any structural isomers. So no structural isomer. They don't have any structural isomer. So structural isomerism start from C4H10. C4H10. So let me consider C4H10, C5H12, C6H14, C7H16. Now kids, just apply one formula, 2n minus 1. That's all. Nothing else is required. Just remember this formula, twice of n minus 1. And what is n? The question arises, what is n? Here n is equal to number of structural isomers number of structural isomers for the previous one, number of isomers for the previous one, C4H10. We know very well that C4H10 is having how many structural isomers? Or if you don't know, then also you can do one thing, that these are 1, 1, 1. So C3H8 is 1. So the value of N for C4H10 is 1. Just apply twice of N minus 1. So 2 into 1 minus 1. So what you are going to get? Twice of N minus 1. So this is having how many structural isomers? Kids, do let me know. 2 minus 1, that is going to get 1. So definitely 1 is this and 1 more. So definitely the value is going to come 2. Kids, here the students may get confused that, sir, it is coming 1 and you are saying 2. What does it mean? Suppose if I say, I am having 1 brother. So Ramu is my brother. So I will be Ramu's brother. So total we are 2, na? Kids, are you understanding what I am saying? What I said, kids, that these are not having any isomer. They are not having any isomer. So if I am saying this is having 1 isomer, so total they are 2. Like see, CH3, CH2, CH2, CH3, 1, CH3, CH, CH3, CH3. This is the isomer of this. Suppose let me write down X and Y. Y is the isomer of X and X is the isomer of Y. Total they are 2. Are you getting my point? 2. Now here what I am going to use? Twice of N minus 1. What I am going to write? This is 2. So 2 into 2 minus 1. 4 minus 1, how much? 3. So C5H12 will have 3 structural isomers. Are you getting? Now use this formula over here. Twice of N minus 1. So the value is coming out 3 over here. So what I am going to write? 2 into 3 minus 1. 6 minus 1. 5 structural isomers. Are you able to get? Now kids, just apply the formula and do let me know in the chat section what the value of structural isomer is going to come over there. Kids, I'm waiting for your answer. Everyone, do let me know. It is 5. Just apply the formula if you are able to understand. If you are able to understand. Killer science, thank you, thank you. 9, very good, that everyone is able to understand. Twice of N minus 1, so 2 into 5 minus 1, that is coming out 10 minus 1, so this is coming out 9, kids. So I hope that everyone is able to understand this trick. Now, this trick will not work for C8 and C10. Do remember, this trick will not work for C8, H18. This trick is not going to work for this, will not work for this, and the trick is not going to work for C10, H22. For these two compounds, the trick is not going to work. Yeah, definitely trick is going to work for C9, H20. Now, for this, we have to find out total number of structural isomers. See over here, 18. So, its structural isomers are 18. 18. You got the trick? Here is 18, so its number of structural isomers are 18. 18. And just apply the trick over here. Twice of N minus 1. So, 2 into 18 minus 1. 18 to the 36 minus 1. That is 35. It's working over here. And this, just remember, it is 75. It is 75. So kids, did you like the trick? Twice of N minus 1. It is working everywhere. Do let me know in the chat section. Did you like it? Did you like it? So one student is asking, sir, why 1 is not added to the number of structural isomer in case of C5H12 as we did in C4H10? Let me tell you. Let me tell you. This question's answer, let me tell you. See kids, try to understand what is isomer. CH4, this is methane. Let us suppose this is human being. This methane is human being. Let us suppose this methane is one human being and its name is methane. Its name is methane. This is the only son. This is the only son. He is not having any brother and sister. So will you say that who is the brother of this methane? What will you say? What will you say? How many brothers methane is having? Brother is just like isomer, structural isomer. But the brother is the relation. Brother is the relation in between two brothers. So how many brothers do you think methane is having? How many brothers of methane? This methane is having how many brothers? No brother, no brother, no brother, no brother, no brother. That means this is the single one. Single one. No brother means no structural isomer. No structural isomer. No structural isomer. Now if I talk for butane, see, butane, C4H10. Now this compound exists in two forms. It can be like this, CH3, CH2, CH2, CH3. Its name is N-butane, N-butane. And another one, CH3, CH, CH3, CH3. This we will say isobutane. Now let me say this is Mr. Butane. Let me call this is one human being. This human being's name is Mr. C4H10. Mr. C4H10. The name of this human being is Mr. C4H10. And this human being is having two kids. One kid's name is N-butane. Another kid's name is isobutane. This is son of Mr. C4H10. This is also son of Mr. C4H10. Both are the son of Mr. C4H10. So Mr. C4H10 is having two sons. So what is the relation in between these two sons? What is the relation in between two sons? Kids, do let me know what is the relation in between these two sons. They are known as what? They are known as brothers. N-butane's brother is isobutane. Isobutane's brother is N-butane. So they are brothers. And so same I will say they are structural isomers. Now kids, if somebody is asking, see, focus over here. If somebody is asking how many brothers N-butane is having, how many brothers of N-butane, how many brothers of N-butane or brother of N-butane? Kids, if somebody is asking N-butane is having how many brother? One brother. And isobutane is having how many brother? One brother. See, isobutane is having one brother and butane is having one brother. So if somebody is asking how many structural isomers for N-butane? One structural isomers for N-butane. How many structural isomers for isobutane? One. Total they are two. Total They are two. Mr. C4H10 is having how many sons? Mr. C4H10 is having 2 sons. Now you got the concept. Everyone do let me know. Everyone do let me know. Have you got the concept how the question can be framed? If you don't know the theme of isomerism, you won't be able to give the answer. If somebody is asking Mr. C4H10 is having how many sons? 2 sons. N-butane is having how many brother? 1 brother. Isobutane is having how many brother? 1 brother. Total how many kids are there? 2. If you got it, show me the thumbs up along with the heart. I have told you kids. Yesterday only I have told you, if you are able to understand the concept, show me the thumbs up along with the heart. If you are not able to understand, thumbs down. Then I am having number of things I can explain that concept, but at least do let me know whether you are able to understand or not. Kids, really good, really awesome, really awesome. Now, let me divide isomerism. Let me divide isomerism. Isomerism is divided into 2 parts. Isomerism is divided into 2 parts. What are these 2 parts, kids? One is structural isomerism. Structural isomerism. This structural isomerism is also known as constitutional isomerism. Constitutional isomerism. Constitutional. Right now, kids, everyone, it's your duty just to keep in your brain. Don't keep the things for later on. Stop procrastination. Right now, try to keep each and everything in your brain. So, structural isomerism or constitutional isomerism, and kids do remember, they will have always different IUPAC name. Different IUPAC name. Do remember, whenever you are going to talk about structural isomers, they will always have different IUPAC name. And what are these? Let me tell you. RT, FM, CP. This is the trick. I will let you know what this trick is saying. But right now, let me tell you the full form of these. R means ring chain isomerism. Ring chain isomerism. T means tautomerism. Tautomerism, kids. F means functional isomerism. Functional isomerism. M for metamerism. Metamerism. C for chain isomerism. P for position isomerism. So what is the trick? RT, FM, CP. What does it mean? RT, FM, CP. If any compound shows more than one type of structural isomerism, then who is going to get preference? First preference should be given to ring chain isomerism, then tautomerism, then functional isomerism, then metamerism, then chain isomerism, then position isomerism. How many types of structural isomerism we are having? 1, 2, 3, 4, 5, and 6. 6 types. Kids, we will see only the isomerism when the molecular formula is same. If the molecular formula is not same, we will never get entry towards this. So, structural isomerism. The compound is not having structural isomerism. Do remember, if the compound is not showing structural isomerism, definitely that compound is going to show what? That compound will show space isomerism. This is known as 2D, two-dimensional isomerism. Now we are moving towards 3D. 3D. 3D means space isomerism. 3D means space isomerism. Space isomerism. And space isomerism is divided into two types. Space isomerism divided into two types, and those two types I'm going to tell you over here. One is configurational isomerism, configurational isomerism, and another one is conformational isomerism, What is the difference in between configurational and conformational isomerism? Kids, what is the difference in between configurational and conformational? That is really very, very important. Let me tell you over here. If I'm talking about configurational isomerism, kids, configurational isomerism. So this is really very, very important. If two isomers are not interconvertible, into each other at room temperature. At what? At room temperature. For example, if I say cis butene can't convert into trans butene at room temperature, so I will say they are configurational isomer. For example, let me say I am butene. Okay, I am what? I am butene. So this is my cis form. Both the hands are coming towards your side. Okay, kids, are you able to understand? Suppose I am butene and my two hands are coming towards your side. I am being cis, and my one brother, this is butene. He is always remaining like this. Can you see? This is butene. He is always remaining like this. So this is, I will be called as cis butene and my brother will be called as trans butene. He will remain like this always and I will remain like this always. I can't be able to convert into butene and he can't be able to convert into cis butene at room temperature. What does it mean, room temperature? Suppose if we are provided heat or any chemical or anything like that, so cis can convert into trans. So that's why doctors always used to give suggestion whenever they are providing some medicine. Don't keep medicine in the sunlight. If you are keeping medicine in the sunlight, then cis will convert into trans, or trans may get converted to cis, and then their metabolic properties will get changed. For example, you must have seen doctors used to say dextrose, dextrorotative glucose. You know dextrorotative glucose, metabolic activity on glycolysis, it produces 10 ATPs, 2 ATPs gets utilized, net gain of 8 ATPs. Then Emmenden-Meyerhoff pathway, that is your citric acid cycle, the eukaryotic and prokaryotic 36, 38 ATPs, you know. So that is being dextrose. Its levulose form is not metabolically active. Kids, are you able to understand what I am talking about? Gopi Ganesh, everyone, you are able to understand what configurational isomerism means? That one form of isomer can't be able to convert into another form of isomer at room temperature, then we are going to use this word. Now see kids, if I talk about conformational isomerism, so see kids, suppose if I am ethane C2H6 and we know that this ethane has infinite conformers. You must have studied in class 11 infinite conformers, and all those conformers are interconvertible. All conformers are interconvertible into each other at room temperature. Now kids, suppose if I say this is Mr. Ethane. Suppose if I say this is Mr. Ethane, and he is a disco dancer. Mr. Ethane is a disco dancer, let us suppose is a Michael Jackson type disco dancer. Now kids, when a disco dancer is dancing, what he is going to do? See, he will move like this, waves, he will create waves, he will move like this, he will do like this, he will move like this, he is going to rotate their fingers like this, like whatever, I don't know, like this, and they are moving, making waves like this, that they are making infinite conformers, that the whole body is rotating. Zumba, if you are suppose Punjabi Zumba like this, Bharatanatyam like this, dum 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 dum. So are you getting my point? That one Mr. Ethane is having infinite conformers. They are making infinite forms. They are moving like this, dung 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 dung, like this, like this. Are you getting my point? Kids, if this is clear, do let me know. Then I will start from structural isomerism, from the very basic. Kids, do let me know if each and everything you are able to understand. Show me the hearts along with the thumbs up. Then I will come to know that yes, each and everything. Are you enjoying? Is everything going in your brain? Kids, is everything? I think for the first time you are studying this isomerism in this way. If yes, do let me know in the chat section. For the first time you are studying the isomerism in this way. Vignesh ji asking, explain with example. When I will teach all these things, conformational, I will teach in detail later on. Will tell you in detail, will let you know in detail at its time. So I will move one by one. Today is the time of structural isomerism, and the structural isomerism, in the structural isomerism, first I will let you know the chain isomerism, then position isomerism. So everyone ready? When I'm going to tell you about configurational and conformational, I will let you know each and everything in detail. Kids, are you able to understand? But right now it is the time to start from the very beginning. So let's start from the very beginning. Are you ready, everyone? How's the Josh? Do let me know. Are you ready, everyone? Tell me, are you ready? So I am going to start from the structural isomerism, from the very basic, from the zero level. Structural isomerism, from zero level. We are going to start from zero level. Zero level up to rank 1. So do let me know, everyone. Are you ready? Everyone ready? So let me start from the chain isomerism. The first one is chain isomerism. Try to understand each and everything and try to keep each and everything in your brain. Chain isomerism. Chain isomerism. So kids, this is the first point about the structural isomerism. In the short, I will use to write CI. Now, compounds having same molecular formula, but different parent chain. Do remember, but what I'm saying, but different parent chain. Do remember this point. Their parent chain should be different. Their parent chain must be different. Then they are known as chain isomers. Will you keep this thing in your brain, kids? Always keep, otherwise not be able to solve the question. You won't be able to give me the answer right now. Promise me, each and every one, you are going to keep each and every part of this, each and every word of this in your brain. Then only you will be able to solve the questions. Now see to it. If I say example number one, C4H10, I can write like this: CH3, CH2, CH2, CH3, and CH3, CH3, CH3. See these two compounds, both of them are having molecular formula like this. Same molecular formula is same, but this compound's parent chain is of 1, 2, 3, 4. PC is of 4 carbon atoms. And in this 1, 2, 3, parent chain is of just 3 carbon atoms. PC is just of 3 carbon atoms. So the parent chain is different. So they are chain isomers. Clear to all of you? Write down yes. If this is clear to all of you, write down yes. Don't waste your time. Show me the thumbs up with yes. Everyone, show me the thumbs up with yes. Let me give you another example. Let me write down C5H12, CH3, CH2, 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 CH3, 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 CH2, CH3, 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 CH3. Get see to it. If I do the numbering 1, 2, 3, 4, 5, PC is of 5 carbon atoms. 1, 2, 3, 4, PC is of 4 carbon atoms. 1, 2, 3, PC is of 3 carbon atoms. So they all together, what will you say? What is the relationship they are having? If I say this is your N-pentane, this is your isopentane, this is your neopentane. What relationship they are having, kids? They are chain isomer of each other. Are they structural isomers? Yes. All chain isomers are always structural isomers. So I would like to say all chain isomers are always, all CI are always structural isomers. So this statement is true or false? Kids, do let me know. If I'm writing all CIR always structural isomer. This statement is true or false? Do let me know in the chat section. This statement is true or false? True. Very good. Very good. This statement is absolutely true. They all are brothers. They all are brothers. So Mr. C5H12 is having how many kids? If anyone is asking, Mr. C5H12 is having how many kids? Means how many structural isomers? Kids? 3. Very good. You are able to understand each and every point. That's really awesome. That's really awesome. Fantastic, kids. Now, if you are able to understand, you have to answer 3 questions important for NEET. I'm going to ask total 3 questions, very, very frequently asked questions. Frequently asked questions in NEET. See, question is, find out total number of chain isomers in first one is alkane, second is alkene, and third is find out total number of, better to write total number of, your minimum number of, better to write, find out minimum number of carbon atoms required, to show chain isomerism, in. This is the question, kids. Question is, find out the minimum number of, what I am writing, minimum number of carbon atoms required. You are supposed to find out minimum number of carbon atoms. What is the question? Find out the minimum number of carbon atoms required to show chain isomerism in alkane, alkene, and third question is alkyne. So total 3 questions, and these questions are frequently asked. So first of all, tell me for alkane. First of all, tell me this question, alkane. Kids, everyone, I want to see your answer for alkane. Everyone, do let me know. Yes, everyone's answer is correct. Alkane is 4. This is awesome answer given by you, kids. So answer is 4. Its answer is 4. Absolutely correct. Now, just do let me know for alkene. Do let me know for alkene. Alkene. Kids, do let me know for alkene. I want to see for alkene. Everyone, let me see the chat section. Let me see in the chat section what's your answer, kids. 3. Most of the students are writing 3. Some are writing 5. Oh, great. Number of different types of answer I can see in the chat section. Wrong. So, Vignesh ji, Cherry Baby, your answer is right. Bhumi Kataria, your answer is wrong. Santosh ji, your answer is wrong. See to it, kids. Its answer is what? 3 is wrong. Its answer is also 4. Should I explain? Let me explain it on another page. Let me explain over here. C4H8. This is alkene because CnH2n. So CH2 double bond CH, CH2, CH3, and CH2 double bond C, CH3, CH3. Now see to it, kids. Here the parent chain of 1, 2, 3, 4. PC is of 4 carbon atoms, and here PC is of 3 carbon atoms. PC is of 3 carbon atoms. So kids, 4 is the minimum number of carbon atom which is going to show chain isomerism. They are CI. With 3 carbon you won't be able to form CI. Let me show you. With 3 carbons you will never be able to form CI. Let me check it. No, such 3 carbon ring will be considered not. If you are going to make ring, Bhumi Kataria ji, if you are going to make ring, that will be known as ring chain isomerism. Bhumi Kataria ji, are you listening? If you are going to form ring, that will be considered as ring chain isomerism. That is not going to be the chain isomerism. Everyone, now see, next question. Alkyne. Do let me know what is the answer of alkyne. Everyone do let me know for alkyne. What is your answer? This we have done, this we have done. Now, fast, be quick. Alkyne, Vignesh, definitely correct. 5 is the correct answer. Somebody is writing 2. No, you cannot form. Its answer is 5, kids. Answer is 5. Answer is 5. Let me tell you how. Alkyne is C5. If I am writing C5, then we know that CnH2n minus 2. So 5 2s are 10 minus 2. So it should be H8. Now let me find it out. Okay, you will say, sir, you are the teacher, you know 5. How we are going to find out? Let me first tell you, it should be like this: CH triple bond, C, CH2, CH2, CH3, and CH triple bond, C, CH, CH3, and CH3. See to it, everyone. See to it. 1, 2, 3, 4, 5. Parent chain is of 5 carbon atoms. Now here, 1, 2, 3, 4. Parent chain is of 4 carbon atoms. So total number of carbon atoms are 5. Below these 5 carbons, you won't be able to form chain isomerism. Let me show you. Suppose if you are trying for 4 carbon atom. Let us try for 4 carbon atoms. Suppose if I am writing C4H6, let me write down CH triple bond C, CH2, CH3, CH triple bond C, CH3, CH3. See kids, what's wrong over here? Can you see anything wrong? Here the valency has become 5. Can you see this carbon's valency has become 5? Valency of carbon is 5. Valency of carbon is 5. That is wrong. So this structure is absolutely wrong, kids. This structure is absolutely wrong. Not possible. This is not possible. This structure is not possible. So this structure is wrong. Agreed, kids? Are you able to understand? So C4, 4 can't be possible. With 4 carbons, can't be possible. So the answer is 5. Kids, do let me know. Are you able to understand this thing? Everyone, do let me know in the chat section. Are you able to understand? You got it? If you liked it, show me the thumbs up along with the hearts if you really liked it, kids. If you are enjoying these notes, the isomerism, do let me know in the chat section. I want to see, kids, the bonding between me and you. And do remember, today is Sunday. You haven't got any class. So I am going to explain each and everything about the chain and position isomerism. Promise karo. Just do the promise. Make a promise with me. You are not going to leave the class. Most of the students just after 1 hour's class, they are thinking like, oh, we are tired. Just in 1 hour, how kids you can get tired? You have to become doctor. Now, let me start with position isomerism. Let me start with position isomerism. Kids, see to it. Position isomerism. So, see the definition of position isomerism very clearly. It's going to be really very important. Compounds with same molecular formula but different position. See kids, one more thing, let me rub this and let me tell you where you are going to make mistake. Let me tell you one more thing. Compounds with same molecular formula and same parent chain, because here you are going to do mistake. Same parent chain also, same parent chain. If you don't understand this thing, you are going to make a mistake. Remember that, same molecular formula, same parent chain. This is the point to be noted, my lord. Compounds with same molecular formula, same parent chain, but different position of alkyl or multiple bond or functional group What I'm saying, kids? What I'm saying? Position should be different. Position. I'm talking about position. Remember, position of. Not I'm saying the functional group should be different. What I'm saying, their position should be different. I'm talking about their position should be different. This is the most important point. Position of either alkyl group or multiple bond or functional group. This should be different. Then we will say they are parent chain isomer. Kids, whenever we are going to deal with this parent position isomerism, that is PI, we are always thinking of chain isomerism. Kids, do remember, chain isomer can never be position isomer and position isomer can never be chain isomer. Why? In position isomerism, parent chain is same, but in chain isomerism, chain parent chain was different. So chain isomer can never be position isomer and position isomer can never be chain isomer. Are you getting my point? Everyone getting my point? Just do let me know what I'm saying. Important point, most important point, what I'm telling you, kids. Most important point, what I'm telling you, kids. Chain isomer can never be position isomer or position isomer can never be chain isomer. So chain isomer can't be position isomer and position isomer can never be chain isomer. This statement is true or false? Do let me know. If you are able to understand, do let me know this statement is absolutely true or false. By chance, if in assertion reasoning it is coming, suppose the question for assertion and reasoning is coming. Assertion and reasoning question is coming. What will you write, kids? So this statement is absolutely true. Now kids, I'm going to explain each and everything with the help of examples. See to it. False one. Killer science, it's not false. It's absolutely true. Now see to it. Now I'm going to explain. Kids, I'm going to explain. See to it. Suppose if I'm taking C6H14, C6H14, and if I'm writing CH3, CH2, CH2, CH3, CH3, 1, 2, 3, 4, 5, 6. Now I'm taking another example, CH3, CH2, CH, CH3, CH2, CH3. Now try to find out, kids. In the first example, the parent chain is of 1, 2, 3, 4, 5. What is the number of carbon atoms in the parent chain? Parent chain is of 5 carbon atoms. And here 1, 2, 3, 4, 5. Parent chain is of 5 carbon atoms. In both the two cases, what I can see, the parent chain is of 5 carbon atoms. So they can't be chain isomers. They can't be chain isomers. Are you getting my point? They can't be. They are not chain isomers. They are not chain isomer. Now see, in this, what I did, I'm saying this is the parent chain. And in this is the parent chain. So what is left? Kids, what is left? Only the thing which is left, this methyl, and over here this methyl. Over here the position of methyl is 2, and in this case the position of methyl is 3. So the position got changed. Kids, are you able to understand? The position of alkyl group is changed. Can you see? Everyone do let me know. Are you able to see? Are you able to understand? The position, the only thing, the position of alkyl, the position of alkyl is changed. Alkyl is changed. So what are they? What relationship they are holding, kids? Kids, what he is saying, Vignesh, sir, if you consider N-hexane and isohexane have different position, they are chain isomer to N-hexane. I will consider, let me take it. Kids, okay, I am going to explain Vignesh's question. Vignesh is saying, if you consider isohexane and N-hexane, okay kids, first of all, let me tell you, these are position isomers. Is it clear? Everyone first do let me know, is this point clear? If this is clear, show me the thumbs up along with the hearts. Give hearts to yourself that you are able to understand, not for me. Just give hearts to yourself that you are able to understand. Then I will explain, then I am going to consider Vignesh's question. Then I am going to consider Vignesh's question. So Vignesh's question is, question from the audience, question from chat. So I am the one who is going to take your questions. Can you see? Questions from the chat. What is the question? Question has been asked, N-hexane and isohexane kids, do let me know. Let me write down. N-hexane is like this, CH3, CH2, 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 1, 2, 3, 4, 5, 6. This is N-hexane and this is isohexane. Kids, you have to answer it. I'm not going to answer it. You have to answer it. 1, 2, 3, 4, 5, 6. Do let me know what is the relation in between N-hexane and isohexane. N-hexane, this is isohexane. Kids, everyone do let me know what I taught you. Try to understand and try to, yes, everyone's answer is correct. See to it, everyone. See to it that 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Here the parent chain is of 6 carbon atom and here the parent chain is of 5 carbon atoms. So definitely they are chain isomers. Now kids, how many of you want trick for it so that you should never get confused in between chain isomer and position isomer? Do let me know. Do let me know in the chat section how many of you want to get one awesome trick so you should never ever get confused in between chain isomer and position isomers. Let me know. Let me know in the chat section. Let me know in the chat section. So I'm going to give you awesome trick. Awesome trick. Awesome trick. Kids, see to it. Fantastic trick. Or better to say, what? Must trick. Must trick. See kids, you have to understand one thing. Number of carbon atoms in the parent chain plus total number of substituent starting from carbon. This you have to understand. What is this? What does it mean, kids? NCPC and NSC. NCPC and NSC. See to it, everyone. What is it? N for number of carbon atoms in the parent chain. In parent chain. So this much lengthy, you can also take only one letter from it. I will say number of carbon atoms in the parent chain. Let me take C as the boss from it. Now this N stands for number of substituent starting with carbon. So from here also let me take one word. Let us suppose S, number of substituents, S. So I can make shortcut of this CS. Let me call it CS. This is being C and this is one S. CS. Are you able to understand CS, everyone? Do let me know. Everyone, are you able to understand CS? For this I have written NCPC and for this I have written NSC. NCPC, NSC, NCPC, NSC. Let me tell you, if NCPC, NCPC and NSC, that we can say CS. If CS number is same, or let me say different, if it is different, first let me write down for different. If it is different, then I will say they are chain isomers. They are chain isomers. Chain isomer. Now any question of the world, you can solve it. First point, if this is different, they are chain isomer. If this is same, NCPC plus NCPC and this number NSC, or we can say CS. If the value of CS is same, if it is coming out same, then I would like to say they are position isomers. Position isomers. It must be looking little bit lengthy, but once if you are going to focus over here, you will find it really very easy. So what I said, In short, what I'm saying, see to it everyone, what I'm talking about, if CS number is different, if CS is different, do let me know what you're going to say. If CS is different, I will say chain isomers. If CS is same, if CS is coming out to be same, I will say they are PI. Now how to find out CS? The question arises, how to find out CS? Everyone ready? How to find out CS, kids? Everyone, are you ready? Everyone say, leave. If anyone is talking unnecessarily, leave that. Just try to focus on yourself. This is known as how to find stillness in the chaotic environment. Real student is one who is able to find out peace, stillness in this chaotic world. Number of people must be chaotic, number of things they must be talking about. But if you're not getting diverted, if you are finding your stillness, peace of mind, fullness of mind, and if you are doing your work with the perseverance, persistency, in spite of number of obstacles, difficulties, diversions, you are going to get the rank. Kids, leave those twins. Ignore them. Ignore them. Right? Ignore them. Now let's find out CS. Everyone, are you ready? Just like CS, computer science. It's not computer science. What I've told you the meaning of CS, NSCPC. Right? Everyone ready? Everyone ready, bolo? Hey, great boys. Just do let me know, are you ready to find out what is CS? It's not computer science. It's not computer science. What is the meaning of this CS? NCPC, NSC. NCPC, NSC. Everyone say NCPC, NSC. NCPC, NSC. NCPC, NSC. Let's create this song. NCPC, NSC. NCPC, NCPC, NSC. That is CS, 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 CS. Now we are going to find out. Now we are going to find out what is CS. NCPC, NSC. NCPC, NSC. That is being CS. We are going to find out. We are going to find out what is CS. Now see, kids. See. Everyone see to it. See. If I am going to write CH3, CH2, 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 CH3. I am going to take your example only. This is being N-hexane, N-hexane, and CH3, CH, CH3, CH2, CH2, 1, 2, 3, 4, 5. Now kids, C means, what is C? C means total number of carbons in the parent chain. Total number of carbons in the parent chain. So let me find out C. C stands for total number of carbons in parent chain. So tell me total number of carbons in the parent chain, how much you are going to get? 1, 2, 3, 4, 5, 6. So 6. The value of this is 6. Now how many substituents are there? How many substituents are there? 0 substituent. So the number will come out that CS, C is coming out 6. And this is coming out 0. So this is coming out 6, 0. Now in this compound C, 1, 2, 3, 4, 5. Now just to let me know, it is having one substituent. One substituent, kids, one substituent, and parent chain also of 5 carbon atoms. So what is CS number of it? What is your CS number? What is your CS number? Just give me your CS number. Just let me know what is the CS number. So CS number is 5 1 5 1. The CS number is 5 1 and here the CS number is 6 0. Are the CS numbers same or different? Do let me know. CS number are same or different? Kids, CS number is same or different? Do let me know, everyone. Is the CS number same or different? Everyone, just do let me know. CS number is same or different? Everyone, do let me know. CS number is different. Once the CS number is different, what you are going to say? When the CS number is different, what you are going to say? They are chain isomer or position isomer? Do let me know. Everyone, if CS number is coming out to be different, they are chain or position isomers. If CS number is different, they are chain isomers. Chain isomers. So they are chain isomers. So kids, you can see very clearly they are declared to be chain isomers. Now let me give you another example. This was the first example. Let me give you another example. See to it. Everyone see to it. CH3, CH3, CH2, CH2, CH3 and CH3, CH2, CH3, CH2, CH3. Now in this, just do let me know if you are able to understand. 1, 2, 3, 4, 5. Everyone find out the CS number of this. What is the CS number? Just give me the CS number. In first case, let me know what is the CS number. Everyone just to let me know what is the CS number in case 1. What is the CS number in case 1? 5 1. Parent chain is of 5 carbon atoms and 1 substituent 51. Now let me know in the second case, what is the CS number? This is A, this is B. What is the CS number? Just let me know, everyone, what is the CS number? 51. 5 1 51. Great, great. So kids, do let me know, is the CS number same or different? Everyone, do let me know. What do you think about the CS number? They are same or different? The CS number is being same. So what are you going to say? Are they chain isomer or position isomer? Do let me know, everyone. Hey kids, they are PI. They are PI. Are you able to understand? If you like the logic, do let me know. Also hit the like buttons. I am your HSP Baba. I will let you know each and everything with easiness, with great easiness. I'm going to give you one question. That question is not the question, that is really awesome question. And let me check it out whether you are able to solve it or not. Difficult question, rank deciding question I am going to give you. Rank deciding question. Rank deciding question. If your target is to hit AIMS Delhi, to reach AIMS Delhi, then let me check it out. How many of you are able to do this question? So the question is like this. See to it, everyone. Even many of these students, 99% students get failed while solving this question. Let me check it out whether you will be able to solve it or not. So, what is the CS number over here? Let me know what is the CS number in this case, kids. First case, what is the CS number? Do let me know. In case number 1, what is the CS number? I want to see what is the CS number in this case. First one. Check it out. The parent chain is of 1, 2, 3, 4, 5, 6. 6, some are writing 4, 6. This is 6 and only one you have not to count 62. Oh my God, you are just doing it wrong. See what I've told you. See kids, what I've told you. See what I've told you. Number of carbon atoms or number of substituents? Just do let me know kids. Over here what I've told you, number of carbon atoms or number of substituents, the full form of C and S. What was the full form of S? S, number of carbon atoms in the substituent or number of substituents. Focus over here. See my notes, see my notes. Number of substituents. I've told you number of substituents. Over here I've told you number of substituents. Here I have told you number of carbon atoms. It's known as magic, no trick. Oh, great. Thank you. Muhammad Yahaji, thank you. It's known as magic, it's not trick. Oh, great. Thank you. Lovely child, really. Lovely child, really. It's known as magic, it's not trick. Oh, great. Great words. Now, this is one substituent. This is one substituent. One substituent. Can you see one substituent kids? One substituent. So CS number is coming out 6161. Everyone do let me know, are you able to understand? Now here you can see 1, 2, 3, 4, 5, 6. Now CS number is number of carbon atoms in the parent chain 6. Now number of substituents, one substituent, one more substituent, because this is methyl, this is being methyl, this is also methyl. How many substituents? 2 substituents. So the CS number is 2. So just do let me know, CS number is same or different? Kids, CS number is same or different? Definitely the CS number is coming out to be different. Different CS number, different. So they are what? They are chain isomers. Chain isomers. This was the toughest question. This was the toughest question. It has been asked 3 times in IITJEE and 1 time in your AIMS. At that time AIMS was having definitely means different examination. So kids, are you able to understand? Do let me know everyone. You liked it. Now I'm going to give you one more question for top 10 rank. I'm going to give you one question for top 10 rank. Are you enjoying it? Do let me know. Are you enjoying it kids? For top 10 rank. For top 10 rank. See to it. Get see to it. Everyone see to it. See to it everyone. This is the question for top 10 rank. Yeah, you try to answer it. Everyone, find it out. Let me wait. Let me wait. Okay. This is, I'm giving. Yes, everyone. Sir, but parent chain. Akanya ji is saying, sir, parent chain is same. Yeah, that's why that was the tough question. That's why their parent chain is not same. See, Akanya ji, if suppose there is phenyl, 1-2 parent chain on only one carbon parent chain. See, that's why this is a tough question. That's why this was the toughest question. Suppose if this is phenyl and some functional group is attached over here, you are going to count this to be the parent chain, then 1-2 carbon and this is only 1 carbon. That's why this question was toughest. Akanya ji, Akanya Rath ji, is it clear? Akanya Rachi, is it clear? Akanya Radhi, that's why that question was tough. Now see, what is the PC? Now 6 Mohammed Hanif ji is saying 6 chain isomers. Aruna Kumari ji is saying chain, killer science, chain isomers. Let me check it out. Whose answer is correct? Okay, see to it. Everyone, see to it. See to it, everyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the CS number is total number of carbons 10 and S number of substituents 0. So the CS number is coming out 100. Clear? CS number is coming out 100. Now see to this compound. Everyone try to see this compound. 1, 2, 3, 4, 5, 6, 7, 8. So its CS number is, kids, its CS number is going to be, find it out, its CS number. Number of carbon atoms in the parent chain 8. 8 carbons in the parent chain. Number of substituents. Number of substituent, 1 substituent, 2 substituents. 2 substituents, and there was 0, no substituent. No substituent. Clear to all of you? That's why 0, and here 2 substituents, 2, 82. So this number is different. CS number is coming out to be different. CS number is different. So definitely different. So they are chain isomers. So they are chain isomers. So kids, is this point clear to all of you? If you are able to understand each and everything, kids, super question. Thank you, Muhammad Hanif ji. Everyone, first of all, let me know. First time, I think for the first time, you are studying chain isomerism and position isomerism like this. Is it right? It is true. Am I right? I'm telling you each and everything. Otherwise, in 1 or 1.5 hour, people, they are used to clear each and everything. I don't know whether they are going to clear it or not. They complete the whole structural isomerism. Until now, I have completed, not even completed position isomerism. Just I have started position isomerism, kids. Thank you. Thank you. Your words, your energy, your Josh, that's why only I'm standing over here. This is our bonding, kids. This is our bonding. And that's why for the Sunday, I have not gone anywhere. I'm here for you, kids. I want to see your rank. So always share it to each and everyone. We want to grow this channel. This is our channel, not mine. Our efforts. Now see, I'm going to give you the most frequently asked questions. Frequently asked questions in your exam. See. Frequently asked questions. So your question is, find out minimum number of carbon atoms, minimum number of carbon atoms to show position isomerism in. So the options are alkane, alkene, alkyne, and D is any organic compound. Any organic compound means organic compound of your choice. So these are the 4 questions, kids. Here are the 4 questions. Let me know. Vignesh is writing for alkane, it's 5. Vignesh ji, your answer is wrong. Your answer is wrong. With 5 carbons, we won't be able. Now let me check it out. Others, whether they are able to give me the correct answer or not. And kids, alkane 4. Santosh ji, your answer is also wrong. Satvik, your answer is wrong. Aspirant, Alan, Jakrita, Muhammad Hanif, everyone's answer is wrong till now. Everyone's answer is wrong. Yeah, now Satvik has switched to 7, Akanthyarat 6, Vignesh 6. So 6 is the correct answer, kids. 6 is the correct answer. See, for first it is 6. For first it is 6. Answer is 6. Should I explain? Should I explain? Do let me know. Should I explain, kids? Should I explain? Do let me know. See to it. People have started from 4. People have started from 4. With 4, it's not possible. See, with 4, it's not possible. 4 can't be the answer. See why it can't be the answer. It's wrong. See to it why. If I'm taking 4 carbon atoms, CH3, CH2, CH2, CH3, and now see CH3, CH, CH3, and CH3. Kids, do find out its CS number. 1, 2, 3, 4. Its CS number is 40, isn't it? CS is 40. 1, 2, 3. So its CS number is coming out 31, 31. So they are what? Position isomer or chain isomer? Kids, do let me know. They are chain isomer or position isomer? Do let me know, everyone. Are they chain isomers or position isomers? So definitely the answer is they are going to be chain isomers, and question was for position isomers. They are not chain isomers. They are not position isomers. Kids, are you able to understand? If you got it, if you are able to understand, show me the thumbs up. Then only I can move ahead. Kids, I want to see your thumbs up. Otherwise, I won't be able to move. Now, let me start with 5 carbon atoms. See, if I start with 5 carbon atoms, see to it. If I am going to draw with 5 carbon atoms, see to it. C5. This is also wrong. See why. If I am going to draw like this, CH3, CH, CH3, CH2, CH3, CH3, CH2, CH, CH3, CH3. Both the compounds are identical. See why they are identical. 1, no, numbering is wrong. So I have to start from here. 1, 2, 3, 4. 1, 2, 3, 4. They are identical. They are identical. Identical are also known as, either you can say identical or you can say homomers. Homomers. Same thing. For identical, there is one word that is known as homomers. Homomers. Identical or homomers. So see, they are same compounds. They are same compounds, kids. Are you able to understand? So let me draw with 6 carbon atoms. So let me draw with 6 carbon atom and see to it, everyone. See to it. C6H14, C6H14, CH3, CH, CH3, CH2, CH2, CH3. One compound like this, CH3, CH2, CH, CH3, CH2, CH3. Now see to it, everyone. Everyone focus over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now see to it, everyone. Focus over here. This is having 1 alkyl. This is having 1 alkyl. Parent chain is 5 carbon atoms. So could you please let me know the CS number over here? Its CS number is 51, and its CS number is also 51. So CS number is same. So CS number is being same. So definitely they are position isomers. Kids, are you able to understand? Do let me know with the thumbs up. Yeah, I can see that everyone is focusing on CS number. You have become perfect, really perfect, guys. Perfect. So if you are able to understand till now, just show me the thumbs up. If you are liked it, did you like it? If yes, show hearts for yourself and thumbs up for me. Just show thumbs up for me and hearts for yourself, kids. Now, second question's answer. This was the first part. Now, the second part was for alkene. Now, try to find out for alkene. What's your answer for alkenes? To minimum number of carbon atoms for alkene. I want to see for alkene. Alkane we have done. We did alkane. Now, yeah, I can see the Josh. Really, kids, you are doing your best. And those who are really working hard, their success is waiting for these people. Your success is definitely waiting because really you people are working hard. So, 8. Most of the students are writing 8, 6, 6, 6, 6. So kids, everyone's answer is wrong. Yeah, Vignesh ji, your answer is right. Vignesh's answer is right. Answer is 4. Answer is 4. Now you must got shocked. You must be thinking, what is this, sir? How 4 is possible? See, kids, it's 4. See, everyone, let me write down. It's 4 only. See to it. Everyone, see to it. Let me tell you it's 4. So, let me take alkene of 4 carbon atoms. Alkene of 4 carbon atoms. Get see to it. So, I will take alkene of 4 carbon atom, that is C4H8, right? C4H8, definitely C4H8. CH2 double bond CH, CH2 CH3. Now CH3 CH double bond CH CH3. Now see, kids, the parent chain 1, 2, 3, 4. Parent chain is of 4 carbon atoms, right? 1, 2, 3, 4. Parent chain is of 4 carbon atoms, right? Parent chain is same. 4 carbon, 4 carbon. This is also of 4. This is also of 4. Just what I have told you in the position isomerism. See to it. Let me show you. In the position isomerism, what I have told you. See, kids, what I have told you when I taught you the position isomerism. Let me show you, kids. Let me show you. Position isomerism, where I have told you the position isomerism, kids. See, when I told you about the position isomerism, the position, parent chain remaining same, the position of either alkyl or multiple bond or functional group should be different. Can you see? Kids, can you see? The position of either alkyl group or multiple bond or functional group. So the position of multiple bond, if it is getting changed, if the position of multiple bond is getting changed, they are what? Parent chain remaining same. Parent chain must remain same. The position of multiple bond should get changed. Are you getting my point, kids? So see to it, everyone. See to it. This is your question. You can see to it. Over here the position is 1, the multiple bonds position is 1, and here the multiple bonds position is 2, Kids, can you understand? So definitely 4 carbon is the correct answer. 4 is the correct answer. If everyone is able to understand, show me the thumbs up so that I can understand. Everyone, just do let me know, kids. Everyone, fast, quick. So 4 carbon atom is definitely, kids, this is only the medium in between me and you. Just show me the thumbs up fast. Don't forget, do it fast. We don't have that much of time. Now kids, another question, this one, alkyne. So let's focus on alkyne. What's your answer for alkyne? Do let me know, everyone. What's your answer for alkyne? Don't get tired. And those who have gone, call them, kids. Sharing is caring. Just do call each and everyone. And if you're not, like the channel, purple heart. Thank you, Cherry baby. Thank you, Cherry baby. Wow. We are taking CS number and you are CB number. Good. 2. Sahib Singh ji is saying 2. Deji Villanor is saying 3. SMB is saying 4. So kids, 4 is the correct answer. Vignesh ji is also saying 4. Answer 4 is correct. 4 is correct. Let me tell you why. See to it. Why 4 is correct? See to it, everyone. 4 is correct. See. 4 is the correct answer. It's very simple. If you draw it, you will find it out. CH triple bond C, CH2, CH3, CH3, C triple bond C, CH3. Now you see to it, everyone. If I do the numbering 1, 2, 3, 4. 1, 2, 3, 4. You can see in this parent chain is of 4 carbon atoms. Parent chain is of 4 carbon atoms. You can see in both the two cases, parent chain is remaining same. Only the difference is of what? The difference is of triple bond. Here is the first position and here is the second position. So the position of multiple bond is changed. Position of multiple bond is changed. Kids, can you see? The position of multiple bond is changed. So they are definitely what? They are definitely your position isomers, and 4 is the correct answer. Minimum carbon atoms 4. Minimum carbon atoms, that is being 4. Right? 4 is the correct answer. Kids, you got it? Now the last part of it, any organic compound. Do find it out. Any organic compound. Position, yes, Muhammad ji, position of multiple bond got changed. So they are position isomers. I want to see in the chat section, kids, any organic compound. Do let me know in the chat section. Sir, it can change in 2 bond also. Sahib Singh ji is saying, sir, it can change in 2 bond. Okay, let me check. Let me explain. Sahib ji, let me explain to Sahib ji. Sahib ji, see to it. If we are taking 2 carbon atoms, see. If I am taking 2 carbon atoms, see to it. Sahib ji's question, Sahib ji, from chat section, from chat, I took this question from Sahib ji, that position isomerism with 2 carbon atoms. See, Sahib ji, let me draw 2 carbon atoms, CH triple bond CH. Now only one compound is possible with 2 carbon atoms, so it is not possible. Have you seen, Sahib ji? Only one possibility of compound. Only one compound exists. No other compound with triple bond of 2 carbon atoms. Sahib ji, is it clear? Got it? So kids, first of all, do let me know, I'm taking your questions from the chat section or just I'm simply teaching like other YouTubers of India or world, or I'm taking your questions. Kids, do let me know first of all, everyone. I'm considering your questions, everyone's question from the chat section. Do let me know. Now, everyone, see to this question. Your question was for any organic compound. Any organic compound. What's your answer for any organic compound? What's your answer for? Yeah, definitely. Rishabh Bhatt is saying 3. Let me check it out the chat section. 4. As creator is saying 4. Rishabh Bhatt ji is saying 3. Mizwa 6. Santosh. Sahib ji is saying okay. Everyone. So, everyone's answer is wrong. Everyone's answer is wrong, but kids, let me tell you, Sahib ji has written over there in the chat section, sir, I am in the chat, so I am not able to explain it, but I can prove. Let me tell you, Sahib ji, you must have taken something else also other than carbon and hydrogen. Check it out first. This I am not saying to Sahib ji only. I am telling this word, this sentence to each and everyone when they are talking for alkyne. Alkyne means CnH2n minus 2. That means only carbon and hydrogen. No other functional group, no other atom you are supposed to take. Now let me know, Sahib ji, only carbon and hydrogen you have to take and then draw the structure. You won't be able to draw with 2 carbons. Just to let me know first of all. 3 is the answer. No. I will let you know. Its answer is 2. Its answer is 2. Its answer is 2. Sahib ji, first do let me know. Sahib ji, wherever you are, Sahib ji, what mistake you must have done? You must have taken something else. Other than carbon and hydrogen, you are not supposed to take anything else. Now do let me know. Sahib ji, if you are able to listen, just do let me know. Done. You have done this mistake. Sahib Singh ji, just do let me know. You have done this mistake. Are you accepting your mistake? And this mistake is not yours. 99% students, they do this mistake. 2, I am going to explain. I am going to explain why the answer is 2. I am going to explain. But the mistake done by you, Sahib ji, is done by most of the students. No need to say sorry. This is not only your mistake. This is done by most of the students whenever they are going to solve this question. If we are going to talk about alkene, they will take number of functional group. If we are talking about alkene, and this is the mistake done by most of the students, not by you only. Now, no need to say sorry. You are kids, you are students, and I am your HSP Baba, teacher. So it's the thing. I'm not only teaching you, I'm also trying to rectify what mistakes are done by most of the students, because teachers know what to teach, but this experience shows I have been teaching for 23 years plus. And that's why I'm telling you what is or what are the mistakes most often done by the students. Yeah, hydrocarbons have carbon and hydrogen only, so we are not supposed to take anything. But in this one, in this compound, what they are saying? In this compound, they are saying any organic compound, any organic compound, any organic compound. Now you can take any organic compound now. Now in this, you can take any organic compound. Now see to it. See to it, everyone. Any organic compound. Now, if I'm talking about any organic compound, any organic compound so I'm free, we are free to take any organic compound. First of all, see to it, we are free to consider any organic compound of your choice, any organic compound of our choice, kids. See, we are free to take any organic compound of our choice. Now see to it, everyone. See to it. And Sahib ji, my psychology is very, very, very prominent. See, this compound must be taken by you in that third one. See, check it out. You must have considered this compound earlier. For the earlier question, you must have considered this compound. You must have gone through with this compound. See to it. In the previous question, you must have considered this compound. Now see, kids. 1, 2, 2 carbon parent chain. Parent chain is of 2 carbon atoms. 2 carbon atoms. 2 carbon atoms. 1, 2. Parent chain is of 2 carbon atoms. PC is of 2 carbon atoms. So the parent chain is same. Here 2 chloro are attached on the same carbon, and they are attached on different carbon. This one is known as gem halide, and this one is known as vicinal halide. So how many carbons they are having? They are having just 2 carbons. See, kids. Everyone see to it. Yeah, that is ether and alcohol. Whatever you want to take, you can take. Now kids, are you able to understand this compound? Now everyone, one more thing let me tell you. How many of you gets confused in gem and vicinal? How many of you gets confused in gem and vicinal? Do let me know. How many of you gets confused in gem and vicinal? Do let me know, everyone. Yeah, so you want to get trick? You want to get trick? See, I am going to give you the trick for gem and vicinal. See to it. Trick for gem and vicinal. Trick, mind-blowing trick. Mind-blowing trick for gem and vicinal. Kids, first of all, let me tell you bis. In Hindi, bis means something poisonous. In Hindi, bis means something poisonous, like jealous factor. You can say poisonous or jealous factor. And game, when somebody wants to play game, do let me know, and everyone participate also. If somebody wants to play game like gem means like game. It is like playing games, If we don't know gem, we can pronunciate it game. If you don't know English, you will say game. English is a very funny language. Magical Guru sir, new name. Oh, Cherry baby, you got it. So, If you don't know English, you will say gem, not gem, you will say game. And if you want to play game, you want to come together or you will remain far away. Just to play game, what is required? Closeness is required or you will remain far away. They will closely. Killer Science is saying even PhD chemist, founder of chemistry, can't know these many tricks. Thank you, Killer Science. Thank you. Really thanks. Thanks for these appreciating words. Really, you made my day. You made my Sunday. I was thinking like, I'm going to teach on Sunday. I'm going to sacrifice my Sunday. But kids, really, my God, thank you. Thanks a lot. Really thanks. See, so to play game, come together. Come together. You know, closeness is required. Closeness. Less distance is required or togetherness is required. Togetherness is required. Okay, kids? So they are close to each other. They are close to each other. They are close to each other. Can you see? They are present on same carbon, same field. You can say they are playing in the same field. They are playing in the same field. Now, once the jealous factor is there, then they will go far away. They will go far away. Due to jealous, they have gone far away. They have gone at distance. They have gone far away. Gone far away. Far away. Kids, you got it? Are you able to understand? Are you able to understand? Vignesh ji, thank you. As creator, amazing. Wow, really everyone. Rishabh Bhatt ji, wow, thanks. Oh my God. Oh my God. What is this? Everyone. Misbah, sir, you are legend. Oh my God. Superb. Oh, Priyanka, everyone. So what I could say. I'm full of tears of happiness, kids. Oh my God, really, kids. So, everyone, Gopi Ganesh, HSP sir, Baba HSP, Magical Chemistry Group, what to say? I have no words, kids. Really, I have no words. Kids, let's do two more questions. Let's do two more questions. Then I will finish this lecture. Okay? Really, what to say? I have no words. So many appreciating words. Kids, really. Sir, as creator, when you read our chats and feel happy, like we also get happy when we come in your class. Thank you as creators, really. Kids, in this way, definitely we are going to rock in NEET exam, and this is just the start. This is just the starting. Miswa is writing, you are the best chemist. Oh my God, really. Everyone, all these comments, what you are writing in the chat section, I want to see in the comment section also. Rishabh Bhatt ji, I want to see, and everyone, I want to see these comments in the these appreciating words in the comments also once this video is over, so that I will keep these words with me. Oh my God, Muhammad Hanerji, oh great. I want to keep these appreciating words with me just I will store it and I will keep these words with me, right? Do promise, make a promise, make a bond of promise with me. Yes, cherry baby, wow, killer signs, wow, Gopi Ganesh, wow. See kids, just do promise that you will, yeah. I will see and I will go through everyone's appreciating words and I will give written what? In written, I will give you what I like, okay? Yeah, on Telegram, just after this session, thank you, Rishabh Bhattji, thank you. Just after this session, I am going to give the PDF. I am going to share the PDF. Okay, I am going to share the PDF. Okay. Shubhati Anand Sharma ji, thank you. So let me tell you two more questions. Then let's over this. Okay, see, most frequently asked question is like this. See to it. This is very important question. Very important question. Question is, find out total number of structural isomers for, first is C4H9Cl and second is C5H11Cl. These two are the most frequently asked question. Now let me check it out. I'm waiting for the answer for first one. Or should I give these two questions for homework? Because now it's a lunch time. If you want to take these questions as homework, that we can do. But let me explain, meanwhile let me explain the answer of previous lectures question of, yeah, that I will let you know, Vignesh ji, why the Avengers batch end date is going to get changed or changed. I will let you know. Yesterday's homework, let me see what was yesterday's homework. So, let me see in my mobile, I don't remember, let me check it out. Yesterday's one, and then I'm going to explain. So these two you can say your homework. You can take these two as your homework, and yesterday one, let me see to it. Just wait for a second. Yesterday one. So this was the question, kids. Yesterday I gave you this question, right? Okay. Now see, this is your parent chain. No problem in the parent chain. No, not that one. This is your parent chain, kids. CH double bond CH2. So this is your parent chain. Okay. This is your parent chain. Now numbering should be done from COH 1, 2, 3, 4, 5, 6 and 7. Now kids, you need to know only one thing. Where most of the students did mistake, let me tell you. For that we have to understand one thing. See kids, what we are supposed to understand. See, if I take this compound, see, this is your methane. This is your methyl. We know very well methane. This is your methane. This is your methyl. This is your methyl monovalent. Okay, kids? Now, if I write like this, CH2 double bond, you can say this is methylene, or its another name is methylidine. Either methylene or methylidine, both the two names are correct, kids. Now, if I am having compound like this, CH triple bond, I will say it's not possible. This does not exist, doesn't exist. So it's up to here. Now see, now by chance if I'm having like this, then I will say methylidine because it is unstable. Methylidine, I will say it is methylidine. Now kids, let me tell you, if I am having compound like this, if I am given with this compound C2H6 and C2H5, what are you going to say? This is attached with parent chain. You can say attached with parent chain, with parent chain, with parent chain, or with anything, parent chain. So I will say this is ethane and this is ethyl. This is ethyl. Now, if I am provided with this compound CH3, CH double bond like this, I will say ethylidine, but I can't say ethylene. Ethylene is wrong. Kids, for this ethylene is wrong. Do let me know why ethylene is wrong. The ethylene word is wrong for this. I will let you know why this ethylene word is wrong. But first of all, let me tell you each and everything. If I'm given with compounds like this, CH3, C triple bond, I will say ethylidine. Now let me clear this thing, why this ethylene is wrong. I have to focus over here because this is a really important compound. Let me tell you, see kids. What's the difference in between these two compounds? CH3, CH double bond this, and if I'm going to write CH2 double bond CH like this, these two are different compounds. If they are attached with parent chain or anything else, they are two different compounds. Try to understand the difference in between these two. Yeah, you're right, Vignesh. Try to understand difference in between these two, then definitely you can answer any question of the world. This is ethylidine. The double bond is away from this. It's going over there. Now double bond, see, in between two carbons. See, in between two carbons, double bond is in between two carbons, and from where it has been formed. See, it must be like this, CH2 double bond CH2. What I'm going to say, ethylene. This must be remain as ethylene. Its name must be ethylene, and I have removed one hydrogen from this ethylene. one hydrogen is removed, I will say ethinyl, and this ethinyl is also known as vinyl. This ethinyl is also known as vinyl. This is also known as vinyl. Vinyl, two names are there for this. Either you can say ethinyl or you can say it is being vinyl. Kids, are you able to understand the difference? First of all, let me know, are you able to understand difference in between A and B? Is the difference between A and B is clear? Then I can tell you the name of that compound. First do let me know if it is clear. Clear, okay. I can see in the chat section everyone is writing clear. Now let me come back to that compound which I have given for the homework. See kids, see. Just your answer is waiting for you. See to it everyone. You will get the answer. See, this is ethylidene. This is ethylidene. Can you see ethylidene? And this is ethinyl. Ethinyl. And this is methylidene or methylene. Either you can say methylene or you can say methylidene. Methylidene. I hope this is clear to all of you. Now the IUPAC is very simple. IUPAC is very simple. Everyone can write down the IUPAC now. Kids, are you able to understand? I think now everyone you can write down. Let me write down the IUPAC. Let me write down the IUPAC and check it out whether I am writing wrong or it is correct. See to it everyone. So let me write down the IUPAC. First of all, I am supposed to write this is ethyl, this is ethyl, this is ethyl, this is being your ethyl. So first of all, let me write down ethyl, E-T-H-Y, ethyl, ethinyl. So first of all, ethinyl, alphabetically, first of all, I have to write ethinyl. 5 ethinyl, everyone agreed? 5 ethinyl, 5 ethinyl, then 5 ethinyl, then 6 ethyl, 6 ethyl, then 4 ethylidene, 4 ethylidene. Just check it out, the alphabetical wise, no mistake should be there. 4 ethylidene, then 2 methylene, 2 methylene, then hept, 6 and 1 oic acid. I hope this is clear to each and everyone. Kids, this is all about 5 ethinyl, 5 ethinyl, 6 ethyl, 4 ethylidene. Yeah, absolutely correct. Absolutely correct. Kids, I hope that everyone is able to understand. Everyone is able to understand. If everyone is able to understand, at last show me the thumbs up so that we can end this session. Today's really awesome session, and really today we have formed a very, very strong bond with your Unacademy NEET English channel and all the students for all over India, or I would like to say all over the world. Really, I can see the Josh kids, and today, this Sunday, I will remember forever, forever. I will remember, really, kids. I got lot of love, appreciating words, and really it is forming a strong covalent bond between you and this Unacademy NEET English channel with HSP Baba. So enjoy your lunch. Thanks to all of you. From the internal core of my heart, I am saying, hey Almighty God, bless all these students with all happiness and prosperity. They should be blessed with the fantastic, awesome mind, memory, with great prosperity, each and everything, so that they could get the best rank. They have to get the best rank, and they will get the best rank. In this way, you are going to get best rank. Bye to all of you. Salute. Salute to all of you for this love and respecting and appreciating words which you have shown to me, to your channel. Bye to all of you. Bye bachcha log. Bye kids. Bye kids. So ultimately we have to get the best rank. Yeah, definitely. And we will do each and everything, will provide each and everything whatever is required on this channel for your best rank. Yeah, you will always find these teachers means our team with you people for each and everything, right? Bye to all of you. Bye. Bye.